Hi, algebra peeps. This section that we're going to be talking about today is like, wow. Okay, there is a lot in this section. It it deals with isolating variables. It assumes that you've been taught to factor, which the book doesn't actually teach you to factor until chapter 6, I think. And it's got some really wordy problems. So if you get your workbook out, we will wade through this somehow. All right, it starts on page 117, and it starts out pretty similar to something we've done before. They're giving you a formula, and they're asking you to solve for a specific variable. So you'll notice in this equation here, there are two variables, A and B, but they want you to solve for A. So that means they want A on one side by itself and everything else on the other side. Well, here's the formula that they've given us. To start to isolate A, the first thing we need to do is get rid of this minus 2b. Well, the way we do that is we add 2b to both sides. Let me fire up my magic pen. We will add 2b to both sides. And then these go away, and we're just left with 5a on the left. And on the right, we have 15 plus 2b. Well, now we need to get a by itself. Well, it's being multiplied with a 5. So we need to divide this by 5. I'm not exactly sure what I'm supposed to do with that line, but we had 5a, and we're going to divide it by 5 to get rid of that. And then we just have a on the left, and over here on the right, we divide the entire side by 5. Well, then they break it up into two parts. They break it up into 15 over 5 and 2/5 b. So 15 divided by 5 is 3, and then this is better written as 2/5 as the coefficient of the letter b. Okay? So that would be how you would solve for a particular variable. All right, it gets a little more interesting now. And this is the step where they suddenly expect you to be able to factor. I'm going to show you briefly how to do the factoring, but if you need more help with that, I also added a Khan Academy video on how to factor binomials. He does a real good job of explaining it too. Here we've got, they want you to solve for p, but we have p on both sides. Wish we would have picked a different variable. All right, so the first step, the first thing you're going to do here is they want you to get rid of this minus 7r. You're trying to isolate this 4p, so we're going to add 7r to both sides. Add 7r there, add 7r there. Then that we have just 4p on this side, but we still have this other pq term on the right. Well, we need to get that pq term over onto the left. So we subtract pq from both sides, minus PQ from both sides. Help if the pen would work right. This gives us 4P minus PQ. Now, factoring is basically reversing the distributive property. What happened here was that there was, let me show you this. Here is what it would have looked like before we distributed it. Okay? This is what happened. They distributed the p to both of these terms and got 4p minus pq. All right? So when we factor, we undistribute. Okay? We ask ourselves, what common factor exists in both of these terms? And we see that this one has a p and this one has a p. So we can divide out the p's. And then we're basically undoing the multiplication. So we're pulling those p's out and we're leaving what's left, the 4 minus q, in the parentheses, right? Now you could think of it this way, 4p minus pq. Come on, keep writing. Think of it this way, is you're just dividing out a p from both of these, all right? When you do that, you're left with 4 minus q. And then the p goes back to its original place before it was distributed. So that's the step they expect you to already know how to do. See, here they've got it already written in factored form, p times 4 minus q. And then over here, these pq's wipe each other out, and we just have 16 plus 7r. Okay. Now our goal is to get P by itself, and it's being multiplied with this expression 4 minus Q. So what we need to do then is we need to divide both sides by the 4 minus Q. What am I doing? All right. So they divided both sides by 4 minus Q, and you get this hideous looking fraction thingy, but you've successfully isolated P. All right. So then we get down here to this check. Let me see if I can scroll the screen up just a tad. All right. They've given us 2V equals W plus V over T. And they want us to solve for V. Okay. Well, what we would do is, in order to get rid of the 2 that's being multiplied with the V, we need to divide this by 2. Okay. But this is kind of a little janky over here. If you divide this whole thing by 2, it gets a little confusing and maybe overwhelming for some of you. But let me simplify it by saying, when you divide by 2, that's the same thing as multiplying times 1/2. So this is really W plus V over T times 1/2. Well, you know, when you multiply fractions, 1 times W plus V is going to give us W plus V, and T times 2 gives us 2T. And that's how it would look. Are we having fun yet? Yeah, I hope you have your Starbucks and your fuzzy blanket, because this is going to be quite the trip today. Okay, yeah, I know this looks like a lot of writing, but believe me, there are worse ones to come. And then there's one where I finally just say, no, I'm not doing this. This is example 3. Solve literal equations for a given variable. All right, so they've got this area of a trapezoid formula. A represents the area, H represents the height, B1 represents the length of one base, and B2 represents the length of the other base. Solve the formula for H. They want you to get H by itself, okay? So the first thing you have to do is you're going to have to multiply both sides by 2 to get rid of this hideous looking fraction. So that's what they want you to write in here, that you multiplied both sides by 2. Then these would cancel out. Now we have 2a on the left, and we just have h times b1 plus b2. We're trying to get h by itself, though, so now we would divide both sides by this expression, the b1 plus b2. See, we divided this side by b1 plus b2, and this side by b1 plus b2. These cancel out, and leaving us just h on this side, and then basically you're just rewriting what they had above here, b1 plus b2, with a pen that doesn't always work. Okay. So then you go over here, part B, find the height of a trapezoid with an area of 70 square feet and bases that are 22 feet and 18 feet. So they want you to use the formula you've created as having solved for H. Okay, so here's the formula for height. And they tell you it has an area of 70, so big A was the area, so we put 70 here. The bases go here, base 1 plus base 2. Okay, they went here. And then they added that together, multiplied that together, and got 140 over 40. And then, want me to divide that? I could divide 120 by 40, but I don't know about 140. 140 divided by 40. 3.5. So the height is 3.5 feet, or 3.5 feet. I'm a lover of fractions, so fractions. Okay, so then we get to the mason jar problem. A mason jar company wants to increase the volume of its cylindrical jars by 6 cubic inches. The company's designer wants a formula that states the height h of a jar given its volume v and radius r. The volume of a cylindrical jar is modeled by the equation v equals pi times r squared times height, or h. Which formula should be used to find the height? If we were solving this for h, we have v equals pi r squared h, and we want h by itself. Well, it's being multiplied by pi and r squared. So what we would do is we would divide both sides by pi r squared. Those drop out, and we get that h is v over pi r squared. So we go over here to look which one of these matches those. H is v over pi r squared, so C was the correct answer. But in part B, they want you to use that formula. So we've got H equals volume divided by pi r squared. And this says the radius of the jar is 1.5 inches, so radius goes here, and the original volume is 30 cubic inches. But what height should the company make its new jar to increase the volume by 6 inches? So the existing jars were 30, but they want 6 more. So we want our new volume to be 36 cubic inches, right? On the bottom we have pi, and they've told us the radius is 1.5. Well, that's just unfortunate. 1.5, and remember, radius was squared. The first time I did this problem, I forgot that, and I couldn't figure out what I did wrong. So radius was squared. All right, now what we have is we need to know what 1.5 squared is. I wanted to simplify it a little before I went to put it in the calculator, and I believe it's 2.25. Yeah, 2.25. So then when we put this in the calculator, we can do 36 divided by pi times 2.25. And I get that 5.09, maybe 3, something like that. So the answer is that's the height that they should make the new jar to increase the cubic inches by 6. And it gets better than this. Look at all the words on this page. I am like, oh my gosh. Most of this has been filled out for you. They're trying to show you a real life example of this, but I'm sorry, I don't think anyone in their right mind would actually solve this problem this way. Oh, well, let's just go through it. The total amount of money Kishi spends on pizza for a party is T equals 1349 C plus 1549 P. T represents the total amount of money she spends, C represents the number of cheese pizzas she buys, and P represents the number of pepperoni pizzas she buys. Part A. If Kishi has $85 to spend on pizza, describe the constraints on the formula. Well, the maximum number of cheese pizzas she can buy is 6. Because if she buys 6 cheese pizzas, you go 6 times 13.49, and that would exceed, it would be less than $85. But if she buys 7, it would exceed $85. So absolutely can't buy any more than 6 pizzas. The maximum number of pepperoni pizzas Kishi can buy is, well, let's see, she's got $85, and we divide that by the price of a pepperoni pizza, $15.49. These people should go to Marco's. It's way cheaper. All right, the most pepperoni pizza she can buy is 5, because I'm getting 5.48, and she can't buy a part of a pizza. You got to buy a whole pizza. So the most she can buy is 5, because she can buy 5 pepperoni and 0 cheese pizzas without going over her budget. So the minimum number of each type of pizza she can buy is 0, because you can't buy negative pizza. Right? So part B, solve T equals blah, 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 blah for C. Okay, so they want to get C by itself. So the first thing you're going to do is they're going to subtract this 1549P from both sides. Minus 1549P. Oh, this is so super hard to write so small. Very small writing. 49P. Subtract those from both sides. Now these are gone, and all you have on the right is 1349C, and the minus 1549 is on the left. Then you want to get C by itself, so you divide both sides by 1349 to get rid of that, and here you have the equation solved for C. Then it goes on to say, okay, so if she has $85 to spend on pizza and she has to buy 3 pepperonis, what's the maximum number of cheese pizzas she can buy? So you put $85 in for the total, and you put 3 in for the number of cheese pizzas. No, pepperoni. She needs 3 pepperoni. So you put 3 in for the pepperoni pizzas, and then you multiply these two numbers together, and then you do 85 minus whatever you got for that, and you get this, and roughly 2.86. So how many cheese pizzas can she buy? Can she buy 3? No, she would go over. Okay, 2.86 is the most she can buy without going over. Therefore, the most cheese pizza she can buy is 2. Are you having fun yet? I think there's like 8 examples in this section too. Video games. Ella makes a video game that becomes very popular. She creates a formula, P equals 40C minus 300, to model her profit P, given the number of copies sold, C, taking into account the $300 fee she has paid a retailer to sell her game. Which equation would model how many copies C must be sold to yield a specific amount of profit? So basically they're saying, here's your original equation. If we solved it for C, which one of these is right? Well, I like to do it myself. I'm a visual person. So we'd have 40C minus 300, and I want to get C by itself. So I would add 300 to both sides. And that gives me, oh, that was a bad line, P plus 300 equals 40C. And then I would divide both sides by 40 to finally get C by itself. And I would get that C is equal to P plus 300 divided by 40. And it looks like D was the correct answer. Okay. Dimensional analysis. How fun is that? I don't know how they managed to just stick this in this section somehow. When using formulas, you might want to use dimensional analysis because it sounds super fun to say. And you can tell your friends, oh, I use dimensional analysis to solve this problem. Whatever. Basically, it's how to change units, okay? As you plan your solution method, think about what units were given, what units you need for the solution, and the steps you need to take to convert your units from what you were given to what you will need for the solution. So there's a lot of variation in this, and you can set this up your own way. Basically, we're converting units. Sometimes we're just going to be like converting cups to gallons, and sometimes we're going to be converting minutes to weeks, and sometimes you're going to want to convert rates where you have minutes and weeks, and you're converting to, years, and well, you get what I'm saying. All right, so it can get really big. Mark is purchasing an above-ground swimming pool. If the salesperson says the pool will hold 97,285 liters of water, if 1 gallon equals 3.785 liters, determine approximately how many gallons of water Mark's pool will hold. So the way we do this is it says 2 ratios can be used to compare liters and gallons. You can put gallons over liters or liters over gallons. Both of these fractions are equal to 1 because 1 gallon is the same thing as 3.785 liters. And same can be said for this one. So because the top and the bottom quantities are identical, this is equal to 1. Okay? So we can use this conversion factor to change the amount of liters the sales lady gave him and find out how many gallons. Okay? Now here's how we're going to set it up. Since we're starting with liters, you have to think, well, I guess you would put, it holds 97,285 liters, okay? Think of this as a whole number. So this is like in the top of the fraction. When we choose which conversion factor we're going to use, we want to use the one that will cancel out liters and leave us with gallons. So we pick the one with liters on bottom here because this one has liters on top, and liters will cancel, like have it done here, and we'll be left with the gallons we wanted to find out. Okay, so then this is on top and this is on bottom, so you're going to have this number divided by this number. Handy dandy calculator. I know when I was putting this lesson together, I was like, wow, this is really a lot. And I like how they stuck it at the very end of the chapter. It's like, okay, here's everything else you need to know about this chapter in one section. Okay, so it looks like, and I'm rounding here, I've got 25,703 gallons roughly. So that's dimensional analysis. It makes you sound really smart. Okay, now chefs do use dimensional analysis because if there's anything weirder, it's like cups and quarts and pints. Why didn't they just make those all uniform? Why are some of them 4 and some of them 8 and some things are, what were they thinking? Should have just made it all 10. Just like, well, I guess that's called the metric system, isn't it? Okay. For the chefs to prepare the dishes for the next hour, Adelina needs to provide them with 96 cloves of garlic. However, she can only purchase bags of whole heads of garlic. If each bag of garlic contains 3 heads and each head has about 8 cloves, then how many bags of garlic should she purchase? What assumption must Adelina make when calculating how many bags of garlic to buy? Well, the assumption is that each head of garlic has exactly 8 cloves. Because we're going to do the math, we got to assume they're all the same. We're not assuming the chefs need 96 heads of garlic. We're not assuming the chefs need 96 cloves of garlic. We know that. And each bag has 3 heads. We know that. What we are assuming is that each bulb has 8 cloves, which if you've ever used fresh garlic is not necessarily a given. How many bags of garlic should Adelina purchase? Now, I know what they want you to do here. They want you to set this up. She needs 96 cloves. They want you to complicate this, okay? And imagine that over 1. Well, how many cloves come in a bag? In 1 bag, or how many cloves? There's 3 heads of garlic and each one has 8 cloves, so that's 24 cloves in a bag. And then the cloves cancel. And you will end up with 96 divided by 24, and shocker, surprise, it is 4. So that's dimensional analysis, changing units. Okay, see, here's where their examples start to get a little scary. I don't like it when they put this many words on a page. It kind of is overwhelming. It's overwhelming for me as an adult, and I can't even imagine what you as younger people feel when you see these. A recipe calls for 20 fluid ounces of milk. If Nita buys half a gallon of milk, how many batches of that recipe can she make? And here's where we get into the cups and pints and quarts and things. Notice they've given you all the information you need to know to solve the problem. You have to convert gallons to fluid ounces, okay? Well, you start with the half gallon that she bought here, okay? And now we're going to change gallons into quarts using this ratio, okay? We put gallons down on the bottom, so it will cancel with gallons on the top, and then we'll be left with quarts. But then we want to change quarts to pints, so we use this conversion factor with quarts on the bottom, all right, so that we'll be left with pints, and then the quarts cancel. Now we need pints down here so that we can get pints to cancel, and then we're down to cups. Once we get to cups, we know that there are 8 fluid ounces in 1 cup, so we put cups on the bottom and 8 fluid ounces on top, and then we arrive at a solution, okay? So what you would do here is you would go 0.5 times 4 times 2 times 2 times 8. You want me to do it? I'll do it. Fine, I got this. Just give me a second. Boy, when you guys come back, somebody else is doing this job. Put one of you on calculator detail. Times 2 times 8. 64. I'm sure that was here somewhere if I'd have looked for it, but whatever. Okay, so Nita has 64 ounces of milk. Each batch calls for 20 fluid ounces. Look how much they want to complicate this. You could do this in your head. If you have 64 ounces of milk and each batch takes 20, how many batches can you make? 3. Duh. So you have 4 ounces left. Maybe you have a cat. All right. So that's that. So complicated. Oh, it's still milk. What is with all these dairy people? On average, a dairy cow produces 832 ounces of milk a day. About how many gallons of milk does a dairy cow produce in a year? So this is an example where I was kind of alluding to where you've got 2 things you're going to have to change. You know how many ounces they give you a day. They want to know how many gallons, and you know how much they do a day, but they want to know in a year. So they're changing both things, okay? Here's how you're going to set this up. We know that an average dairy cow produces 832 ounces of milk in 1 day. Okay? Now, we've got to change ounces to gallons, and we've got to change days to years. All right. let's go ahead and tackle ounces. Ounces. We'll put ounces here. And what do we know? Let's see. We know that 1 cup is 8 ounces. So let's use 1 cup is 8 ounces. Okay. And now we need to get rid of cups. And we are going to use this one. 1 quart is 4 cups. 1 quart is 4 cups. And then we want to get rid of quarts. And we know that 1 gallon is 4 quarts. All right, finally we got to gallons. That's where we needed to be. But now we have to fix days. Well, days was on the bottom, so we need days to be on top. So they cancel. And we want years. And I know there are 365 days in 1 year. And so basically what you do is you take your 832, you divide by 8 equals, divide by 4 equals, divide by 4 equals, times 365 equals. So since I have no children to do this for me, 832 divided by 8 equals, divided by 4 equals, divided by 4 equals, times 365 equals, I get that your average cow produces 2,372.5 gallons per year. Well, I guess I'm supposed to do it this way in 1 year. Forget about that. Oh, so the answer was B. Okay. Are we having fun yet? Okay. When I looked at this one, I am just, not today, Satan. Not doing it. Nope. Not this girl. It's late. I'm tired. This looks like a nightmare. Basically, someone's reading a novel about somebody named Aiko who can run long distances. And she wants to know if he could maybe beat the Olympic record for running. I don't know, because like maybe she really cares about running or something. I don't know. But this whole thing is to try to change 16.5, how do you even say that, per seconds, into 26 miles in 126 minutes. No. Maybe if you were here in person, I might torture you with this, but not like this. No, not today. All right, so I have started a new thing. Since some of you are not watching the videos and need to be, I am going to make the video an assignment now. All right. On McGraw-Hill, there is an assignment called video question or something, 2-7 video question, and it's worth a practice grade. And it has one question, and this is it. During the video, there was a picture of a blank wearing a mask. The correct answer is, of course, bus. So when you go over to McGraw-Hill to get credit for watching this whole long, painful video, you answer question 1, school bus, and you will get 100% for a practice grade. Okay? And after this, we just have the practice problems, which we do those in class because that's just how we operate. All right? So thank you for sticking with this whole long, torturous video. This was not a fun section for either of us. I promise I will not make the practice or the test quite as heinous as all this. And I'll see you guys in class.